of an advantage actually with this. Well, I guess it's 1 plus with the whole video thing is we can, if you miss class, we can record it. So the power reducing formula, let me do this cosine again. I think I did this one, no problem. What this should be will be cosine alpha over 2 is the square root. That's the cosine. So just check your notes. This is the one for cosine. And then this is the one for tangent. And at the beginning of class, we did the one for sine. But so those are your half-angle formulas. So what we can do, if we have the sine of 30 degrees, we find that's 1/2. Well, what about the sine of 15 degrees? Now, there's something that the author mentions in the textbook that's really important. And this can be something that can sometimes so just to make an important observation, and when you're working on calculus homework especially, but probably, certainly this as well, it's tempting to do this, but it's not true. In general, this is not the case. I mean, if you let, say, alpha be 0, then yeah, you could say this is true for alpha is 0 because the sine of 0 is 0. But in general, this is not going to be the case. And same thing. Same for the other trig functions. In general, this is not true. So, half-angle formula to compute, say, sine of 15 degrees. But I want to make one more note. One other thing to mention, it has to do with the plus and minus. So these formulas have plus and minus square root of something. Now, this does not mean, and this is a note that the author makes, but this does not mean you get 2 answers. Because usually with square roots, when we get plus or minus, it usually means 2 answers. Not in this case. That's not what the plus or minus means in this case for trigonometry. Now, in algebra, that's the case. But in this, what's going on here is it has to do with quadrants. So we have to look at the angle, and the angle will tell us which quadrant we're in. Give you a second to write that down. We'll look at a couple examples here. But again, the plus and minus doesn't mean 2 different answers. What it means is you have to choose plus or minus depending on your quadrant. So what does this look like? So 22.5 is 45 divided by 2. So if we take a look at the path angle formula, it's plus or minus the square root of, check this again, 1 minus cosine of 45 degrees over 2. Now, when it comes to choosing plus or minus, it depends on the quadrant. (22.5 degrees) is in. So we have to choose the plus or minus. You could choose it from the get-go. So if we think about 22.5 degrees, well, 22.5 degrees it's somewhere in this first quadrant. So we have to ask ourselves this question. Is sine theta or negative in Q1? And that's when we decide, do we go with plus or do we go with minus? So in quadrant 1, sine is always going to be the y coordinate. So keeping that in mind, actually in quadrant 1, all the quadrants, sine is always the y coordinate. And in the first quadrant, the y coordinate, or the sine function, is positive. So that means when we choose between plus or minus, we're going to go with plus. So that's where the plus or minus come in. We have to choose plus or minus depending on which quadrant we're going to be in. And in that quadrant, well, is that trig function going to be positive or is it going to be negative? So in the first quadrant, sine is always going to be positive. So that means we're going to use the positive version of this. Now again, cosine of 45 degrees, this is one of those canonical angles. So that means it's something you're going to find on the unit circle. And if you look on your unit circle, what you'll find is that the cosine of 45 degrees, or the x-coordinate for 45 degrees, is square root 2 over 2. And again, you take the square root of a quotient, you break the square root up on the numerator and on the denominator. And we're going to get this. So that gives you the sine of, say, 45 degrees. But we wanted the sine of 30 degrees. That's sort of what we started with. But let's do something a little different than sine. Let's go with cosine. What's cosine of 15 degrees? Let's cut 30 degrees in half. So again, we're just going to use our half angle identity. No, let's do something a little different. No, let's go 15 degrees. We'll do that. So just to review, now cosine of 30 degrees. Well, that's adjacent over hypotenuse, or rad 3 over 2 over 1, or rad 3 over 2. So that's how we get the cosine of 30 degrees. So great, but let's get 15 degrees. Now again, we come up with this, and I'm sort of doing a lot of review here, but it's just sort of how all this ties together. How you can come up with it is that you take your equilateral triangle, and you cut it in half. Use your Pythagorean theorem. And you get this, or we knock this over. And so just using geometry, just using some basic geometry in the Pythagorean theorem, we can take an equilateral triangle, cut it in half, use the Pythagorean theorem to find the missing side. And that gives us this triangle. We get the cosine of 30 degrees, rad 3 over 2 over 1. And that's how we get cosine of 30 degrees. But now we went through all this stuff to come up with double angle formulas, power reducing formulas, and then finally these half angle formulas. And now that we've gone through that journey, we can come up with the cosine of 15 degrees. So the cosine here, this angle will be twice whatever this angle is. Now again, we've got to decide plus or minus. And 15 degrees well, again, that's going to be in that first quadrant. So this is going to be where cosine is positive. The cosine is your x-coordinate. And the x-coordinate is positive in Q1. So that means cosine theta is going to be positive. So that means when choosing between plus or minus, we're going to go with the plus. Again, if I'm going too fast, let me know. So cosine of 30 degrees. Well, if we look this up on our unit circle, it's the x-coordinate for 30 degrees. And that's rad 3 over 2. Again, I'm doing 2 over 2 just so I have a common denominator so I can combine things. And that's going to be our answer. And just to throw in a review for this right here, you can break up the quotient or the square root of the quotient like that. And the square root of 4 is going to be 2. And we've insisted on the positive square root. So any questions about that for half angle formula? We're able to create some formulas for angles on this. And let's say we know the cosine of 15 degrees. What about the cosine of 7.5 degrees? Well, again, and this is also in the first quadrant, so I'm going to go with the positive version of this half-angle formula. Well, we know the cosine of 15 degrees now. And again, this angle in here will always be twice the angle out here. So we now know what this is. Now it gets a little hairy. Oh, right. So it starts to get a little complicated. Hang in there. Almost there. Again, we have the square root of a quotient. So that will give us the quotient of the square roots. So that is going to give you the cosine of 7.5 degrees. Now, if you had to calculate, that's doing it by hand, but you can do it. And so for some reason, if you can't measure using a protractor, what would be the aid of a protractor to get some accurate measure of 7.5 degrees, say a triangle that has an angle of 7.5 degrees in it, this would give you an exact value. Now, you might be really dedicated to doing things by hand and say, well, I'm going to do the square roots by hand. That's another story. But you can do that. That is possible. There's a neat way of doing it to get decimal by decimal as you go. But probably more practically, if you've got a calculator, you can come up with an exact value for cosine of 7.5 degrees on paper, and then if you have the liberty to do the square roots on the calculator, that would be nice. So that's how you could come up with that. And so you can use this half-angle formula to come up with these different angles, non-canonical angles. So that's your half-angle formulas. There's a great summary of these. It's on page 699. So it gives you your sum and difference formulas, it gives you your power reducing formulas, and it gives you your half angle formulas. So any questions about those? All right. So that takes us past the midpoint in Chapter 6. Chapter 6, as far as sections go, is kind of short. I think we're done at 6.5. 6.4 is the last section of identities. 6.5 we're going to be doing something with trigonometric equations. And those are kind of neat because you have to be kind of careful. So 6.1, we call these product to sum formulas. And I'm going to write them up here first, and then I'll derive one of them. I'll follow derivation in the text. And again, they come from the sum and difference formulas. So if you're interested in saying, well, how can I come up with all these identities? They actually come from one root, essentially, or one seed, if you will. They sprout from, and that is the sum and difference formula. If you know your sum and difference formulas, you can derive your double angle formula, your half angle formulas, and then you can derive these product to sum formulas. So let me give you what those are. And again, they're also in the text. They're listed in page 705. Let's take a look at them. So sine of alpha, sine of beta, and then we have cosine, alpha minus beta, minus cosine, alpha plus beta. This will be the same thing, but we're going to add so this is your sine times, that's your sine times sine, that's your cosine times cosine. Now we're going to mix it up a little bit. We're going to consider when you have the cosine of alpha and sine of beta, or the sine of alpha and the cosine of beta. So sine, sine, cosine, cosine. Now we mix it up. So let's go sine alpha, cosine beta. So that's your sine alpha, cosine beta. And instead of dealing with cosines, we're dealing with sines. So the sine is first. That's positive. I don't know if that means anything. Well, I mean, algebraically it does, but thinking of a way if you wanted to memorize these, looking for patterns. I know I use some unusual patterns, like for certain math formulas. Some sort of homely patterns, I guess you could say, involving dogs or cats. Anyway, moving on. So sine alpha plus beta minus sine alpha minus beta. So when we mix up sine and cosine, when the sine is first, got a positive. When cosine is first, do a negative. And you can tie this into actually a calculus formula. The derivative of sine is positive. The derivative of cosine is negative. We haven't done calculus yet, unfortunately. Again, preview of coming attractions, as they say. So there we go. So these are our product to sum formulas. So let's derive one of these. And we're going to derive it using the sum and difference formulas. Again, those sum and difference formulas are fairly important. So we're going to compute and what this one was for was the sine of alpha, sine of beta. So that was equal to this here. So I'm going to follow the procedure they use in the book, which I think is fairly responsible. I don't expect a textbook to be irresponsible. You never know. So let's compute this part first. Cosine of alpha minus beta. So what this means is you're going to look up your difference formula for cosine. So take a journey into the past. I'm going to go to section 6.2 here. And looking at 6.2, I have cosine alpha, cosine beta, plus sine alpha, sine of beta. So that's our difference formula. Now what about our sum formula? Well, cosine alpha plus cosine beta, looking it up, and this is on page 684. So we have cosine alpha minus beta, cosine alpha plus beta. So now we just need to take the difference of these two. And so what do we get? Well, if we're thinking ahead, we're going to look for things that cancel. And so let's say you're very familiar with your identities. And you might see this cancellation coming along. So since we're subtracting, we're going to get this. And what we're basically doing is verifying this identity. We have sine of alpha sine beta is equal to this difference. Cosine alpha minus beta minus cosine alpha plus beta. So we're verifying this right side to see if we get something like this. So Oh, I'm sorry, I forgot my 1/2. Critical thing. Just squeeze a 1/2 in there. So it's 1/2 times this difference. Now we have the difference. So what we're going to get minus and minus will be plus. So those are going to cancel. And we're going to be left with 2 sine alpha sine beta. Now, so far, we've only taken the difference of this and this. Now we're going to bring in this 1/2. So with the 1/2, so here's the difference we just calculated. Now we're going to multiply this difference by 1/2. And so this will become the 1/2 and the 2 are going to cancel. We're going to get sine of alpha sine of beta, which is what we wanted. So again, if you know those sum and difference formulas, you can derive these as well. So any questions about that? All right. So let me do an example here. So let's say we're going to calculate the sine of 8x times the sine of 3x. Well, we're just going to plug things into the formula. So identify your alpha, identify your beta. So there's your alpha, there's your beta. So what this will be, let's see. So cosine of alpha minus beta minus cosine alpha plus beta. We take that whole thing, we multiply it by 1/2. That's the formula. So plug in alpha and beta. So alpha was 8x, beta is 3x. So plugging those in, This will be 5x minus cosine of 11x. And they don't simplify beyond this. So any questions about this? I'll be honest, I'd want some other simplification, but we'll let it go. All right. So the last thing to mention in this section, and it's going to be the last set of identities we're going to be looking at. Is this. It's the sum to product formulas. And it's page 706 is where you see the listings for these. So again, I'm going to list them up here and then we'll derive one of them. So there's sine plus sine. Oh, equal sign in it. So there's our sine plus sine, our sine minus sine. And then we're going to look at cosine. So there's cosine plus cosine. And then we have our cosine minus cosine. And the interesting thing with the cosines, when you're dealing with these, we have cosine and cosine for plus, sine and sine for minus. When we dealt with sines, we had, let's see, sine and cosine, sine and cosine. We mixed them up. And that seems to be kind of a pattern here. When you're dealing with cosines, you have things grouped together. And when you're dealing with sines, you tend to mix the trigonometric functions together. All right, so let's derive one of these. So let's do this one. Grab a pen real quick. So what we're going to do, let A equal alpha plus beta over 2, and B alpha minus beta over 2. So what that's going to give us is 2 sine of A cosine of B. Now, what we can do is, let's go back to our product to sum. So keeping in mind, we're going to have 2 sine A cosine B, where A is this, B is that. Now for a product of sum, sine of A, sine of B is 1/2 cosine of A minus B plus the cosine A plus B. Oh, sorry, minus. That was our product to sum. Oh, I'm sorry, we're doing cosine. Cosine. It's not something a little fishy. So we're doing sine A cosine B. So again, product to sum. So that's our product to sum formula. Now, what we're going to do, we're going to remember that A is alpha plus beta over 2. And then B is alpha minus beta over 2. So what this will give So if we combine things, what we're going to get now, when we do this minus, we're minusing this entire numerator, alpha minus beta over 2. So again, combining terms, we'll have 2 alpha, and then the betas here are going to cancel out. So we get 2 alpha over 2 plus the sine. And then the alphas are going to cancel out. We'll get a beta. Negative negative becomes positive. So what we're going to end up getting is something like this. And that'll simplify too. Well, this will just be alpha. And then we'll have these canceling. We'll get 2 beta over 2. Sine beta. Now, we have a half here, though. Now, if you recall that we started out with this. And again, we're verifying this identity. So we started out with this, and we called this A, and we called this B to get 2 sine of A cosine of B. And then, focusing on this, we came up with 1/2 sine of alpha plus the sine of beta. So what's going to happen if we substitute this in for this? Well, then we're going to get the formula we're looking for. And that gives us our derivation. So basically what we just do is we just work with the product, the sum formula, and that gives us this summed product formula. So let's do an example, and then those are it for the identities. Oh, almost out of time, so let me do a quick example. So let's say the sine of 9x plus sine of 5x. So again, we're just going to follow our formula. So again, we want to identify alpha and beta. That's your alpha. That's going to be your beta. Squeeze this in here. And then simplifying. And that's going to be our answer. So any questions about that? So what's going to happen, we have one more section before the test, but I do want to talk about the identities a little bit. We're going to do an identities review on Thursday. I think that's what we're going to do, is just go through these other 4 sections from chapter 6 before getting into 6.5 and just sort of review everything with identities, just get familiar with them, working with them. We'll go section by section and do some practice problems. As far as memorizing them, I have a hard time memorizing these. And so what I'm not going to ask you to do something that I'm not doing. So I'm not going to have you memorize these. So that means you'll have an opportunity to put notes together where you can write out all the identities. I think that seems fair. Other than that, again, we're going to review on these on Thursday and just get more familiar with them, get more practice, do some tougher problems, and then we'll finish with 6.5. So that's the plan. Any questions about that? All right. Well, you have your quiz. Your quiz is posted. Again, it's due next Friday, not this Friday. Next Friday in the evening, 11:59 p.m. 10 tries to get all the questions on the quiz right. And that's how they're formatting it. You have 9 questions on the quiz. You'll be able to do all the questions on the quiz, and you get to 10 attempts to get all of them right. And if any questions, let me know, and then I'll post another quiz after that, just to, well, maybe, yeah, probably after that. So I'm giving you extra time and the extra tries, just because it's our first quiz. Future quizzes, there'll be a shorter amount of time and probably not as many tries. So get comfortable with this one and let me know if you have any questions, and have a wonderful day.